Now what if we add two periodic signals, or what if we multiply two periodic signals? Will we still get a periodic signal? Let's see what happens. So you take an x of t signal which has a period, let's say t1, another signal y of t which has a period t2. Now if you add them together, okay, would they be periodic? So if they are periodic, what does it mean? Let's call the additive signal to be z of t, which is equal to x of t plus y of t. If z of t was periodic, then we will say that there will exist a capital T such that z of t plus t is equal to z of t. And this capital T is the period of z. Now what is this capital T, or how to find this capital T? If this capital T is finite, then what does it mean? Then it also means that x of t plus capital T plus y of t plus capital T is equal to x of t plus y of t, right? So which means this capital T here should necessarily be some integer multiple of t1, because you can just compare this side and this side, okay, and then say that okay, this necessarily means that there is some integer such that nt1 is equal to t, and this is equal to the same scenario for y. There exists another integer such that mt2 is equal to this t. So what does this tell us? This tells us that t1 by t2 is equal to m by n. So in order to find this capital T, we need to find out these integers n and m. Okay. So how can you find those integers? Basically, you take this ratio t1 by t2. So if this ratio t1 by t2 is rational, what do we mean by rational? Rational number is any number where you can express that as some integer a by another integer b. So if you can express a given number as a ratio of one integer to another integer, then you claim that number to be a rational number. So if t1 by t2 is a rational number, then we can find out the corresponding integers. And once you find the corresponding integers, you can find out t from here. Okay. So if t1 by t2 is not rational, for example, let's say t1 by t2 turns out to be something like pi by 2. This is not a rational number. Hence, this will become an aperiodic signal, meaning this signal we have here will be aperiodic if the ratio t1 by t2 is not rational. If it is rational, something like say 5 by 2, it's a rational number. Okay? So, or let's say this is 22 by 7, this is still a rational number. Okay? So, for such kind of ratios which is rational, we will be able to find the period. So, what is the period in this case? So, in this case, the capital T is equal to 7 times T1. So, this ratio is, and which is also equal to 22 times T2. Okay. So, you can find the time period in this fashion as long as the ratio is rational. Now, what if instead of addition we had multiplication here? The same, exactly the same analysis follows, and still we'll have the same result. So which means for both kind of combinations where you add signals or you multiply signals, as long as the ratio of the signals that you're working with turns out to be a rational number, then you say that the combination of these periodic signals will also be periodic, and you can find the period in this fashion, okay, by computing these integers that are present in this rational number. Let's take some example. So let's take the addition of sine t plus cos pi t. What is the period of sine t? We know that what is the period of sine t, right? Because sine t plus 2 pi is equal to sine t itself. So the period here is 2 pi. Now what is the period of cos pi t? Cos pi of t plus 2 is equal to cos pi t plus 2 pi, which is the same as cos pi t, which means period here is 2. Now what is the ratio of these two periods? The ratio of these two periods is 2 pi by 2, which is pi. This is irrational. Hence, this is aperiodic. Even though individually they are periodic, when you add them together, they become aperiodic. Well, let's see this example. Now, what about e power minus j3t? Is this periodic? Let's see what happens. So, e power minus j3 t of t plus 2 pi by 3. What is this? This is equal to e power minus j 3t plus, or take the minus outside, minus j 2 pi. So e power minus j 2 pi is just 1, which means this entire thing disappears. Then we get the same signal back. This implies that this is periodic with period 2 pi by 3. What about tan 2t? Tan of 2t plus pi is tan 2t plus 2 pi. Once again, this is same as tan 2t itself. So which means this has a period which is pi. What about their ratios now? Now the ratios is 2 pi by 3 by pi, which is 2 by 3. This is rational. Hence, this is a periodic signal. And what is the period? It's easy to find this period because now you have this ratio 2 by 3. So all you have to do is now just multiply 3 with 2 pi by 3 or 2 with pi. So the period is 2 pi. The combined period in this case is 2 pi. Okay. All right. Now we saw what happens to the periodicity when you add two signals or multiply two signals. Now what happens if you do a time shift or a time scale? What happens to the periodicity? So clearly time shifting does not affect the periodicity. Why is that? Because you have a signal something like this. No matter by what amount you move, x of t plus t will still be equal to x of t. Now let's say I'm shifting a given signal by some b amount. Okay, so just because I've shifted it, it does not change this property because it will still satisfy x of t plus b plus t should still be equal to, I can say that this is some v, right? So this is saying v plus t, and this should be equal to x of v by the property of periodicity. So that is still true. So it doesn't really matter. You take a periodic signal, you move it around. Just because you are moving it around in time does not change the fact that it is periodic, right? You can still copy any portion and then you can still keep repeating it or tiling it and you'll get the periodic signal. That property does not change. All you're doing is shifting the origin. It doesn't really matter where the origin is. Remember, once again, periodic signal, you can start at any point and then you can just take the time period length to be equal to the actual period of the signal and then copy that portion and keep repeating it. Because the point at which you're starting does not really matter, what the origin is also does not really matter, and hence time shifting really does not affect periodicity. But time scaling affects periodicity. Why is that? That's because you are stretching or compressing the signal. If my period was 1 second and I stretch the signal to 2 times, then it means the periodic signal now will have a period of 2 seconds. So if I had, let's say, a periodic signal which looks like this. So this is -1 and +1. Now if I stretch this signal, let's say I stretch it to this extent, clearly my period also increases, right? Or if I squish it, so as you can clearly see, the period becomes smaller when you squish the signal or compress the signal, and the period becomes larger when you stretch the signal. So when does the signal get stretched? The signal will get stretched when the scaling factor is less than 1, and the signal will get squished when the scaling factor is greater than 1, right? So the corresponding period increases when the signal gets stretched, and the signal, when it is compressed, the corresponding period decreases. In other words, how do we mathematically say that? If x of t is our time scaled signal which has a period capital T, then the new period will be t divided by modulus of a, because it doesn't really matter if there is time reversal or not. If a is negative, there is time reversal. Once again, it does not really matter if the time reversal is happening to the periodicity, because even if you flip the signal or if you take the mirror image, the periodicity does not change. You can still copy any t length portion of the signal and then tile it, and still it will be periodic. So because of that reason, we include a modulus or absolute value here, so that the period is always positive. We don't want this number to become negative. Okay. All right. Let's see some examples.